Hey everyone, hi, good afternoon, good evening, good morning, depending on which part of the world you're joining from, of course. How are you all doing? Let me quickly go and check across platforms if you're live. But if you're there, you're seeing me live, then please feel free to comment hi or anything so that I can know that you're there. And it is always good to see familiar faces. Let me also check in parallel as we're speaking. So we stream across various platforms so that people can join from whichever mode of um, learning or communication they are most convenient with. But it seems okay. Let me just check. Yeah. Okay, cool. This is working. Yeah. If we are not streaming live, it really we never want anyone to miss out if they have joined in. So it seems that we're live across platforms. I'm just going and checking myself also. By the way, this is AI Planet. For those of you who do not know, I'm one of the founding members of AI Planet, and we are a global community of data science. We started a couple of years ago with a vision to educate and build AI for all, to solve some of the meaningful problems out there. And over the given period of time, they've been able to build a community of over 100,000 plus data scientists from 150 plus countries. But the crux is, as a data scientist or as an AI enthusiast, let me say, if you come onto aiplanet.com, you can learn from some of the best data scientists like Parth out there for absolutely free. And you can also contribute towards building meaningful solutions. We're also launching a very interesting concept of AI marketplace pretty soon. So if you're a part of the community, you will get to explore that. You can get your hands on it. You can see if you can integrate into your product and everything. I see a comment from Daniel saying your platform is one of the best. Thank you, Daniel. You're the best. Thanks for that comment. And I think we're live across platforms. I see a comment from Jayesh, who's an old friend and uh, is the founder of Petroleum from Scratch, data scientist, and is a partner of AI Planet also. So I welcome you all to this particular live session on AI Planet. Uh, and in this session, we'll be learning about distributed deep learning, distributed machine learning. The idea of this goes, I think Parth, who's on the background, is the best person to introduce um, um, you know about this topic and everything. But basically the idea is that as the scale is increasing, as the amount of data possibilities are increasing, it's we need to move to a different kind of system where we are taking advantage of it in a more seamless and more effective manner, and that's where this comes into place. Horovod, Spark are more of the tools that helps you achieve it. Parth, who will be talking about it, is a very seasoned data scientist. He's currently working as the chief data scientist of a market research giant called Jasper Collins. He has an experience in distributed ML applications and system design. So he has trained over 2,500 students to date in data science, machine learning, deep learning, NLP. So he's somebody who's absolutely passionate about startups, building products for some of the most innovative companies out there, and educating people around AI and data science. So we are absolutely thrilled to have him here. Let me quickly add him to the stream without any further ado. So yeah, hi Parth.
Hello, Mudit. Thank you so much for having me.
Thanks to you, Parth, for being with us today. I understand, you mentioned on the backstage that you recently were ill, you were hospitalized also, but it's very kind of you to take out the time to be with the community. Thank you so much for that.
No, thank you so much for having me on this platform, and to all the viewers who are watching this currently. If I cough a little in between, I know it can get a little irritating, but I'm so sorry. But I'm gonna try my level best to have this session as informative as possible, and hope that you guys learn something out of it.
Yeah, sounds great. So we can dive into it probably, and I'll go to the backstage. The stage will be all yours. For those who are joining us, they can ask any questions if they want to. I'm not okay. Yeah, you can put it in the comment section, and we'll be curating it. And try to ask questions if you have any. If you don't, it's absolutely okay. But you can put them in the comment section. We'll be having a look at it for sure. Okay, over to you, Parth.
Thank you so much. Thank you so much for everyone for joining this session. And I will just take this session one step at a time. And please tell me if, first of all, my screen is visible. And then I'm going to quickly check up on the audio if it's audible. And then we should just get started with that. Okay. I'm assuming my screen is visible. Can someone give me a heads up?
Yes. Yeah, your screen is
Yes,
visible.
it's visible.
Yeah.
Okay, all right. So, thank you so much for joining, guys. So, today, the topic that I am intending to discuss is distributed deep learning. And there are a couple of tools out there that help you solve the problem of, you know, data science approaches that you currently have day to day in organizations and businesses that deal a lot of that deal with a lot of problems. And one of the tools that really stuck with me and I've worked with a little extensively is Horovod and Spark. And we've used both these tools to solve some of the problems currently we had in our organization. And that's sort of one of the reasons why we're talking about it today. So before I deep dive into distributed deep learning, I'm so sorry. One of the problems that as a data scientist we sometimes encounter is uh, for a couple of organizations that are sometimes service oriented or sometimes maybe D2C or B2B, there sometimes happens that you have received a lot of data and now you want to do a lot of effective testing on different algorithms or maybe different models, and you want to have a very quick understanding of whether a particular model works or not. So there are various methods to it, and of course it's also segregated between machine learning and deep learning, right? So uh, one of the most important topic we already have solved is what we have distributed architecture or distributed sort of technology, where uh, what we can do is we can have a particular resource shared across multiple node, and then each node sort of take a responsibility and solve the problem. Now when we integrate that with distributed deep learning, what we try to say is that we want to have a deep learning model. It could be image, audio, video, text based, and somehow I'm able to effectively train it over a multiple cluster. Now, this specifically falls under a portion of computer science called high performance computing, and the tool that I'm going to discuss today is an amalgamation of good data science or sort of deep learning practices with high performance computing architectures and networking protocols, and how a team from Uber decided to reduce their responsibilities on other team. So Horovod, of course, which I will explain forward, is sort of built by Uber. But let me go forward and sort of explain what uh, in terms of distributed architecture model and data parallelism is. Now the most easiest and intuitive way of understanding anything according to me is through analogy, because analogy works for me really well. So how I would explain model parallelism is, let's say you have a big model and this model has a lot of hidden layers. It's a very extensive model with so many hidden layers and so many layers in between, right? And if I decide to split the layers among different nodes or among different clusters, I will call that as a model parallelism. So for the very first input of an image, maybe the first four layers are divided in one node, and then another layer, which is the immediate layer after that, is divided into another node. And then when I say node, I also mean clusters among machines. So that is what I would like to call as model parallelism. And data parallelism is very simple as data sharding. You take a data set, you shard the data set, and I'm talking about incredibly large amount of data sets. So I'm talking about TBs, right? More. So when you shard the database, each data set or each shard goes into a different node or a cluster, and then it gets trained on, right? Now, this is what we call data parallelism. Now, in theory, model parallelism works well. It has its own pros and cons, and data parallelism works its own magic, but it has its own advantages and disadvantages. Now, in practice, data parallelism is something that most API supports are given, and most practical approach towards solving a distributed problem is data parallelism, because here the only problem that you have is at the data engineering stage, where you have to shard the data, and you can of course decide on what sharding strategy that you want to use. It's sort of like if you've implemented MongoDB, we have replica set, where uh, you have a silo or sort of like one data warehouse, and from that data warehouse you sort of take a section or a portion of the data, but you decide how and when exactly is that data sharded, so you sort of control that. So this is the difference between model parallelism and data parallelism. Now, why am I talking about this is in high performance computing, this is already solved. Now, before Horovod, which is the library that I will be explaining now, uh, there are two approaches to distributed deep learning. Is one either is model parallelism, other is data parallelism, right? Now, in model parallelism, like I said, that each section, if you see that the model is too large for a single GPU, so you basically split the GPU into multiple different sections and have individual layers in it. And in data parallelism, you have one single GPU, which is also called local rank, which I'll explain sort of in the further in the further slides. And that's sort of how you split and chunk your data, right? Now, this is an example of a model parallel behavior in neural network way. This is sort of like a very simple example where if you can see that in line oh, there's no line number here. So self.part1.2 torch.device CUDA 0 and CUDA 1. Now what happens is Horovod has solved the problem of distributed deep learning in a very different way. When we deal with high performance computing, the issues that you get is how do you solve a problem of, say, gradient descent, right? If I distribute my data into different shards, like I have 5 different shards, and each shard goes through a network or some sort of a training understanding or a model understanding. But how would each individual model know or converge to a local minima given that it's optimizing through a stochastic gradient descent, right? It needs to have one singular understanding. So certain problems like this arrive when you do data parallelism or model parallelism. So one of the oldest technique that exists is what you call as a parameter server, and it works in a very simple way. Each model or each data cluster or a node sort of does a model training, and it sends the gradients or sort of an updated gradient to a parameter server. And the parameter server is sort of like the bottleneck or sort of like a service which takes all your model understanding into one single cluster. Now, of course, from the very first look of it, we understand that one parameter server becomes a bottleneck. So if the parameter server goes down, your entire service goes down. So it becomes sort of like a system design bottleneck. Now, this problem or this solution already existed way before Horovod, and organizations like Microsoft, organizations like Uber have implemented parameter server in their actual infrastructure. But the problem that it faces is you can have multiple parameter servers, you can have a copy of parameter servers, you can have sort of like a master slave architecture for the parameter servers, and it would solve the problem. But then again, it does not. We have something called asynchronous stochastic gradient descent, which so let's just take an example that there are four GPUs here, GPU 0 to GPU 3. And each GPU, let me call each sort of a GPU server as one cluster, one node, right? And each node takes its own sweet time to calculate the gradients and update it with the parameter server. Some could be fast, some could be slow. Now, parameter server could pretty much handle that load, but it isn't that it isn't that extensive. And that's one of the reasons why a lot of research went into understanding how can we effectively implement a distributed sort of a framework for deep learning based applications, or to introduce deep learning based phenomena in an architecture. So that's where an all reduce or all ring reduce technique comes into picture. This is what Horovod actually uses in its in under the hood, right? What it pretty much does, and there's a long paper about it, and what it does is it splits the entire tasks into different worker nodes, and each worker node sort of shares information among each other. It goes through a lot of different high performance computing protocols like RDMAs and MPIs, which if you've used open MPIs, you must know that each thread or each daemon speaks with another daemon if it's sequential in nature. If not, there is a way they communicate among each other. And there's also RDMA approaches to a different way. So this is what Horovod does in between. And the most beautiful thing about this is it's completely decentralized, right? So that is why Uber engineers shifted from having an old approach of high performance computing, like having a parameter server, to including Horovod in their actual production system and testing out new models very effectively, and that's how they were able to do it. And there's a very big paper by Facebook on this, implementing this particular strategy with a couple of high performance computing protocols, which they were able to, I think, if I remember it correctly, they were using 27,000 GPUs for a VGG16 net, and they were able to get good amount of accuracy, and it was pretty quick. So let's talk about Horovod and how Horovod has helped my organization solve a lot of problems. And we deal with a lot of data as an organization. We deal with a lot of data. So, uh, excuse me. Horovod is a data parallel framework for distributed deep learning. We know that for now. And it's very framework agnostic. So you could come from an Apache MXNet background, you could come from Pytorch, Keras, and TensorFlow. It automatically detects what package you're using in your production, or what package you're pretty much using for your application or project, and it is able to sort of wrap around it very well. So it's easy to use Horovod with your existing architecture. If you use TensorFlow, not a problem. They have support for it. They have good documentation as well. If you have Keras, well, they have support for that as well. Keras from TensorFlow in the background. So pretty much that's sorted. And as I was saying, that the high performance features include NCCL, MPI, IDMA. Now these are protocols that communicate with a certain amount of latency. As we know that when we diverge ourselves into deep learning based aspect, maybe building an application, we also have to look for applications wherein they have a certain latency requirement. Like, say for example, if your data server are sitting all the way in America, and you're sort of building an application here back in India, and you want to have a dev server and a prod server, and then when you test it, there's a certain amount of latency because the center is somewhere far. So as a developer, you are encountering, or you will encounter, some challenges, and sort of Horovod will take care of maintaining that. And one of the main reasons why people use Horovod is it also acts as a mediator between your infrastructure team and your ML team or a DL team. So the infrastructure team can just set up like a Horovod a server, and they can give you a pod that says, hey, here you go, and you can test it out, and pretty much that's it, right? So Horovod was, if you've not figured it out by yet, Horovod is built by Uber, a team of engineering team from Uber. And I mean, thanks to them, they have come up with some really good, I think, methods and collectively good APIs for, I think, the updated Pytorch, which is, I think, Pytorch distributed data parallel. Pytorch also has something very similar, but not very extensive. It's called distributed data parallel, DDP, Pytorch DDP. It also is extensively sort of integratable with Pytorch DDP. Now, one topic or one concept that I think Horovod does when you have to implement Horovod in your production is it goes through something called GPU pinning. Now, what GPU pinning means is, let's say that you have a device, a GPU device, and you can spin up pretty much, let's just say that you have 8 different GPUs in your cluster. Now, local rank is the number of GPUs that you have. So if there are 8 GPUs, then there are 8 local ranks, including 0 till 8, 0 till 7. So you have 0, 1, 2, 3, 4, 5, and all the way till 7. Now, what GPU pinning means is Horovod distributes or sort of divides each task, and each task is given to one singular GPU. And each single GPU is sort of collectively held together through an MPI thread, which maintains the process due of each GPU. And each GPU is given a local rank of its ID, so it's consecutive in nature. And what Horovod does is, with a single method like dot something, you will be able to assign a GPU to a certain task, and it will be able to run that process. Now, the GPU, the way you sort of pin a GPU is oh, I think I have the code somewhere forward, so I'll just sort of explain, right? Another problem is state synchronization. Now, here is what happens even if you have asynchronous stochastic gradient descent. The problem is, if you start any machine learning or any deep learning algorithm would sort of start with randomly assigning a gradient and then sort of minimizing it all the way depending on the function it's trying to solve. But Horovod because it's distributed in nature, it starts with a very lower number, which is very close to zero, and then the sort of the gradient sort of minimizes itself based on the function it's trying to solve. So state synchronization is a technique where across different clusters or different nodes of the compute cluster that you have, uh, what Horovod basically does, it gives you a very singular API to solve that state synchronization problem for you, so that every single cluster that's trying to solve, or that's trying to solve for a gradient, or the gradient descent problem, is sort of uniform across. Because otherwise it beats the purpose, right? If individual cluster has multiple different gradient values, it did not solve the problem. It needs to have one singular gradient, so there is an accumulation at the very end, which Horovod basically takes care of it by itself. And sort of very important, because uh, different algorithms have a different requirement. Like if you use an XGBoost over a light GBM, so XGBoost would have its own stump, so it's sort of like a tree structure, and then it would do calculations a little differently. And if you're using gradient descent based approaches, or maybe accelerated gradient descent, they have their own problems. So state synchronization sort of understands that your approach towards problem solving is either a tree based structure, so let me accumulate gradients, or maybe try and solve your loss function in a little different way. And if it's either a gradient descent based approach, then it sort of synchronizes in a different way. But what it gives us as a developer is an API to take care of it by itself. So under the hood, it does the magic. All we do is call the API or the method, and it pretty much does that for us. So something very important as we work with Horovod, right? Now, I've also introduced a sort of uh, included a sort of like a code or a code snippet for another distributed sampler, which we have in DDP. This is exactly what a root rank equals to zero means as a local rank in Horovod. So Pytorch also approach the problem in a very similar syntactical way. So root rank equals to zero would mean that you're assigning from the number of clusters that you have, GPU clusters, you assign zero to whatever number you have, and then each thing will be pinned to a GPU, and then it's going to solve a problem. So as you look for uh, either a PyTorch distributed data parallel, or you would look for in Horovod, the syntactical similarity is also very, very similar. They have very similar API names. So the documentation, when you read for Horovod, it's pretty much self-explanatory. But if you do go to the Horovod's GitHub page, there are open issues. Currently, I think they have some APIs that don't really function well with couple of approaches. Excuse me. What I've seen specifically in their open issues is, I think they have yet to solve some problems with Spark APIs, PySpark APIs, which I think they will. But if you're planning to implement Horovod, let me tell you one thing, that Horovod works incredibly well when the data size that you have is incredibly large, and the fact that you're facing a lot of problems to experiment with different algorithms, with different techniques. You want to know if uh, you want to take a certain technique to the production very soon, and you sort of want to understand, uh, and you do not want to involve yourself in more of an architectural discussion with your team. You just don't want to sit into those meetings. So Horovod is the solution for that. But Horovod performs better if your data size is larger. At the same time, your cluster size is larger. So if your um, so when I a little off topic, so when I sit with my team, I do a little something called ROI calculation, which is return on investment calculation, and I try to understand how much effort am I putting myself and my team are actually going to be putting into solving a particular problem. And when we realize that, okay, maybe this does not require a distributed approach, it's sort of like saying that um, microservices are good but also expensive. So if you until and unless you don't need a microservice, a monolith architecture will do wonderful. So it's exactly like that. I think there is a trade-off between using distributed deep learning only when you need it, because it is going to increase your expenditure, because you're going to be using cluster. GTX clusters are not very cheap. or NVIDIA clusters when we buy through, the web services are not really very cheap. So um, one recommendation is, it is really good to get a hands-on with Horovod, because I believe high performance computing and deep learning, sort of data science, will because the data size or the data sets are increasing and becoming extensive, right? We see every day over here, every day, that chat gpt, you see that is doing wonder, and they're training it on much bigger data set sizes, and now it's going to be 500 times more potent. That's because all these companies are implementing these strategies of using distributed deep learning or distributed sort of an architecture to solve that problem. So I think one important takeaway that I think I would like to say is, do not use Horovod or Python distributed data parallel, Pytorch distributed data parallel, unless you really need it, because it's of course going to add to your infrastructure cost. And if that's not the requirement, I would request you not to do it, because I think that could be pretty much solved by normal processes. So yeah, I mean, so getting back to the syntactical similarities between the distributed data parallel and this, so you would see sort of like the same similarities. And with PySpark, you can also implement, Horovod. It's very simple. I've given a sort of like a boilerplate code or a sample code here, where you can also implement Horovod with your pipeline, a Spark pipeline, an existing Spark pipeline, and you should be able to sort of return an output, and you should be able to test out a particular technique or an algorithm with a certain set of data that you want, and have a proof of concept for certain production feature that you want in your production. So this is something that we recently used in our organization to solve a problem. We have a lot of different products in the market research segment, and we have some very big clients who wanted a specific feature, but it involves a lot of data processing and different sort of techniques, and we were very confused about uh, if we ship something, how do we make sure it's consistent with the data that they get. And we pretty much had this Spark API for our rescue and Horovod for our rescue, and we were happy that it did what it did, and sort of helped the problem. Yeah, so moving forward. So like I said, Horovod's architecture integrates really well with whatever existing library that you want to use. It could be either TensorFlow, it could be either Apache MXNet, or it could be either Pytorch. And here we can see that there is something called all reduce before prescale and after, sorry, between post scale. Now, here, Horovod under the hood does a lot of things, but one of the most important thing is what is all reduced, but also at the time it does GPU pinning, so it sort of assigns each process a GPU tasks. Horovod simultaneously does a lookup on all the gradient buffers that says, hey, is this task done? And and unless the task is done, it does not move forward, or it sort of waits until the entire process is done. And this could be across the number of clusters that you have. And once the task is completed and the gradients are sort of accumulated, it sort of moves in a very cyclic nature until the entire process is done. So it basically is like doing multiple tasks at the same time to make sure that the entire architecture that you've established via Horovod is very effective in nature, highly decentralized, but also very effective in nature. So I want to include this architectural understanding from Uber about how they do a lot of stuff, a lot of magic under the hood with Horovod. And I think just a fun fact, Horovod is Russian type of dance. So I think if you look at the way they have the logo of Horovod, so it's like multiple people holding their hands in a chain, and sort of like, I think it's a representation of all ring reduce algorithm which they're using. So yeah, I mean, fun fact. Just sort of adding that into the conversation, right? Excuse me. Now there are five simple and easy steps to sort of integrate or start using Horovod with with your existing architecture. The very first step is to initialize the library, and how you initialize is you just pretty much import Horovod And if you're using TensorFlow, here you have the sort of the method of TensorFlow. If you're using PyTorch, you can use PyTorch. And if you've used any existing libraries, it's just like hvd.init, which is to initialize or sort of run the library. It's pretty much the same simple concept. The second step is actually to pin the GPU to each worker. And here we can see that it's doing that with .visible device list, and then setting up a local rank, which is hvd.local rank. What it does is, like I said, if you have number of different GPUs, that many amount of local rank is assigned, and then based on that, it sort of pings each GPU to each worker. Now, there is one other thing I noticed with Horovod. While working with GPU pinning or sort of initializing the Horovod, sometimes while working with sort of like an extensive cluster that you have, you may not have the cluster segregated properly. Sometimes what happens is, let's just say that for a hypothetical reason that I have 8 GPU clusters and I need to split it accordingly, and my pinning doesn't necessarily go with all the 8 pins. So there is, I think by the time I was working, there were no error messages properly about GPU being pinned properly or not. I think there is no way of understanding if certain things have been pinned or all the GPUs are being extensively used. So what you have to do extensively is you have to monitor the GPU cycles from your server or through your servers, and sort of something I think which they should include. I'm not sure if they've included in their existing library, but yeah, I mean, there's no sure way of knowing that all the GPU have been pinned or all the resources of your GPU cluster have been effectively used to sort of your problems that you're trying to solve. So something that I faced, and we sort of did a very we solved this problem using a little different approach. We used to just monitor the health and the memory allocation and the resource of the node or the cluster that we are using, and sort of get a high level understanding whether everything is being utilized properly or not. But yeah, I mean, getting back to how to pin a GPU to each worker, it's a very simple documentation or also a simple method of doing that. And then right after that, this is a very important step, and I think this is also very important. Now, because this is distributed deep learning, there are going to be a couple of hyperparameters that are going to be affected. And the reason they're going to be affected is because you're distributed in your architecture, learning rate will be affected in a very different way. So let me give an example. When Facebook conducted the research, they realized that n number of clusters that you spin, you have to multiply your learning rate with that number. So learning rate into n, and then you have to actually keep adjusting your learning rate, because what you're actually doing is considering data parallelism. You're splitting the data and you're sort of feeding a portion of the understanding of the model that you want to build into a cluster. And then because it's distributed in nature, you will have to adjust or keep constantly adjusting your learning rate, and then and you have to work with that. So what Horovod also does is it gives us this distributed optimizer API or a method. And what this does is, I remember reading about it and I could understand a little bit, but I think I'll try to explain that in analogical term. What it does is it adjusts your learning rate. It adjusts your learning rate based on the number of nodes that you spin up, and also it adjusts depending on the data shard that you have. Now, the sharding of the data that you do could be equal or could be unequal. It could be that an individual cluster might get a little large chunk of data, and another cluster might get a little smaller chunk of data, and or not smaller, or maybe uneven in size. And you could feed that to your node, and then the node would sort of take up in an adjustment to its learning rate. So what distributed optimizer also does, if I'm not wrong, is it also takes care of optimizing depending on the amount of data that you're trying to feed to whatever cluster that you're trying to feed it. So something that Horovod does, and it gives us this distributed optimizer as an API to solve that problem for us. So that it can sort of take care of adjusting the learning rate for itself. You can also have an SLA sklearn pipeline for adjusting that yourself, and you can sort of introduce that as a parameter here instead of just giving it to the Horovod. But it has multiple approaches to it. The documentation is very clean and very clear about this, and there are a couple of blogs out there which explain very extensively about how to sort of wrap and use the distributed optimizer, a technique for a better convergence. And then we have synchronized state across worker. And I think I have shown this to you in this, which is exactly the state synchronization. And now we are actually thinking or looking at it through a programming perspective, or through a program perspective, or a code perspective, where we actually take it as a monitor session, which is mon underscore sesh, and it has something called as a monitor training session hook, and then you sort of train it, and then it's sort of synchronized state across workers. One of the benefit of also state synchronization that I was talking in the previous aspect was uh, the problem that we were trying to solve was more towards numeric data, which was standardized, of course, and it was sort of related to the fintech space. So we had a very wide column data that we were working with, and so every instance that we trained our cluster on, we, I think, were making a mistake, and eventually we realized it long after that. We should have started with like a very sample. I think we took too bigger of a confidence in this library that we thought, okay, we could just put in everything that we have, and sort of realized that we are doing something wrong, because as a team, it was our first time using Horovod, even for for development purposes. So just a just a quick, I think, advice would be that even if you use Horovod, I think it takes a little time, because their APIs have certain name and have a certain technical understanding which I as a developer had never experienced, because before this I've never indulged myself in high performance computing to an extensive level. So sometimes the API's names would confuse a lot because they sound very similar, but they do completely different things. And so the most important thing would be to go through the documentation and knowing exactly what it does. And what we did was, there is an API, or there is this method name that is very close to I think an optimization name. So we assumed that it does some sort of an optimization, and we just wanted to test if it did any optimization. Have we increased any accuracy matrix? Have we increased any prediction score? And it did not. So we were able to sort of understand that, oh, okay, I think we've made a mistake. Let's go back and let's check the name properly, and let's understand what it does, and then sort of implement it. So something, a very naive mistake we did. But yeah, the advice would be, if you want to use Horovod, it's a process. It's going to take a little time for your team to understand and implement it, because there are so many high performance computing instances, topics, techniques, concepts, which it takes a little time for us to go and read through the concept and topic first, because the most important thing is to understand why it exists, right? There is a problem. So the understanding would be to first go through the understanding, like, okay, there was a problem, we understood the problem, and now we know there is a solution by Horovod, which is using this method or this technique. And so um, so sorry, this was funny for us. So yeah, I mean, we sort of realized it long back, and so we actually reduced a data size in, I think, 1/5 or 1/6, and then used that data to test with, sort of play around with Horovod and Spark APIs. And once we were sort of very confident with the predictions that we were getting, we went ahead with a larger chunk of data, and then we were able to implement it beautifully, and then it worked out for us. So yeah, it's always the learning experience. It was really good for me to solve the problem, but yeah, it's always the learning experience with this. Now the fifth step is, of course, as simple as checkpoint on the first worker. Now what I would like to correct here is not just the first worker, but on all worker. And pretty much this is what it does. Once your process is over, once your learning is over, or once that pod is being utilized, it sort of maintains a checkpoint. In Python, we have different ways of having a checkpoint. This is exactly how you can maintain checkpoints on all workers, on all clusters, on all nodes based on the local rank. And you will be able to sort of save that as a session. So this is how we implement Horovod on I'm so sorry. on a simple application. I had an application which I had built using Horovod. Unfortunately, due to, I think, a different configuration in my laptop, now I'm not able to run it. But I hope this session sort of gave an understanding to people about what Horovod is, and how you could sort of utilize Horovod to solve any existing problem that you have with respect to. You could be an organization dealing with a large chunk of data, may not know how to have a framework, or how to sort of solve a problem with distributed computing. There are so many different tools out there, and what sort of solve the problem. We were also confused initially, unless we spoke with an engineer at Uber, and that friend of mine helped me a lot in understanding how to implement this in our production. So it was like a process we went through, and eventually it did help my organization solve some problems with respect to the amount of data that we were dealing and the amount of problems that we were facing. And Horovod came to our rescue, and Spark came to our rescue, and sort of we were able to solve that problem. It was a process of learning because I had never learned it before, and but I'm glad that I was able to understand and implement couple of things over the period of time. So yeah, thank you. And if there's any question, I am more than happy to answer, if there's any questions that anyone has, Mudit. Hi Mudit, can you hear me?
Yes, I can hear you. Sorry, my
Yeah.
browser was hung for a second. But yeah, so thanks a lot for sharing the instances in terms of how was the experience with Horovod and everything in Spark. So one thing that I would quickly want to ask is, like you mentioned, various instances where you got to speak with the team of Horovod. So as somebody who is like an upcoming data scientist, may not have access to data scientists at Uber. So is there a platform or community where they can go and ask related to this?
Oh, with respect to asking questions, I think so. I unfortunately had to use a personal leverage. I had
Okay.
to, personally use a contact in
Yeah.
Uber that I had, and fortunately, that person had access to the team,
Hmm.
which could help me solve the problem. So I was able to, reach out to Uber directly due to the context. But I believe the next community should be AI Planet. I think people can leverage you to maybe sort of gain that.
Yep. Thanks. Yeah, yeah, yeah. I think, and if folks have any doubts, maybe they can put it in the comment section, and if something we can maybe have a part again on the community. There is one question that is um, okay, that is asked by Nilotpal. He's like, how is exactly is the process of setting up Horovod? Can you probably describe it briefly?
Oh, it's very simple. So I think the very first step that you can do, since you're interested, is just install Horovod in your local Colab or a Jupyter notebook. It's as simple as pip install, and once you have the Horovod install, you can just run a very initial script that's mentioned in the Horovod document, and it's like a very simple hello world type script where you can run a very first script with Horovod. So it's pretty much mentioned in the documentation. So it's like a very simple installation. You just do pip install, you install it, import the libraries, and pretty much run it. So it's as simple as that. It's nothing complicated or complex there.
Okay. And I have one question. Like, can you name? Like, I mean, can you share a few use cases where you clearly saw the need for moving towards a distributed ML system versus a
Oh
traditional
yeah,
one? So, yeah.
yeah, absolutely. So we constantly deal with a lot of fintech companies,
Hmm.
and fintech has a lot of data,
Hmm.
and not just the volume of the data, but also the size of the data. So I'm talking about very wide column data. When you deal with something like, let's take an example, Titanic data set example, right? So you have column A, B, C, D, E, F. When it comes to fintech, we have incredibly wide column data set, and then the volume is incredibly hard. So already uh, we were facing problems with different types of fintech companies that we work with. We work with companies that are into lending. We work with companies that are into uh, uh, insurance, we work with companies that are into different sort of B2B lending, so they are very different. So we were facing difficulties with the current architecture, which was feeding in a lot of data. So what we used to do is every week we used to train a model, and then the model would be trained on the new instances of this data, and then we would sort of have an updated model given to the client, and then the client would do its predictions. The weekly updates became 4 days updates, 2 days updates, and there came an instance where we had a company which requested that, hey, I think you need to retrain your models every day nightly. So there were nightly builds every night. We have this huge amount of data, right? And we want you to take an understanding from this data and retrain it yourself. So we realized that I think we have to escape out of an existing nominal understand or architecture, and we have to sort of take a distributed approach where we can test out things very faster, very quicker. At the same time, we can escape this problem that we are facing. So that's where initially we thought of implementing a distributed architecture, and luckily it did solve a lot of problems for us, and currently all our clients are happy, and we are happy as well. So yeah, that solves the problem for us. I think Mudit, you're on mute.
Damn.
Yeah.
Okay. Thank you for pointing it out. So I'm just very curious because this is a case where you mentioned about fintech sector, which is in a particular industry, but a lot of people who are into research, they may would want to understand if that can be used across other spectrums also. So do you have any use case on that? Because I'm very curious to understand, like if let's just a lot of our community members who are into AI research, for them is it relevant, and at what point what point do they decide to move into this architecture? Because
I think it's
yeah.
absolutely relevant. And if someone is from a research background, so I mean, let's take an example of why is it relevant. We
Mhm.
know that when Word to Vec initially came in 2012 by Thomas McCullough, right? It was trained on a certain bigger chunk on data, right? Or like a bigger chunk of data, and we had a good amount of embedding, which is Word to Vec. And then we had transformer based architecture where it was trained on 17 plus billion parameters, and then it was 27 billion parameters. And then what you see is the graph is growing. The data size or the data voracity is increasing. So that means more and more deep learning or machine learning engineers will eventually have to understand the concept of high performance computing. Like, because that amount of data, you cannot do it in a single cluster. You have to have a multi-cluster approach. So if you come from a research understanding, I'm assuming that if you come from a PhD background and you want to implement a different sort of technique or a different architecture of a neural network, you will have a bigger amount of data to work with. So eventually migrating to a distributed computing side of it is only going to end up helping any data scientist to sort of have an extra skill set that says, yes, I have worked with bigger chunk of data, and I think I've worked with distributed side also. So I think this is definitely going to help.
Okay, thanks. And there is one last question. Are there any limitations to using Horovod with Spark for distributed architecture?
That's a very good question. Yes, there are limitations. So Horovod isn't perfect yet. I know for a fact Horovod isn't perfect. And if anyone from Uber is watching, please fix this. So there are a lot of open issues on GitHub pages of Horovod, and specifically most of them are with Spark APIs. So the limitation would be only on certain instances there are errors. The code should work, the the pipeline should work, but it does not. And I think Uber is trying to fix it because Horovod has now achieved a good status among the community of developers. So I'm thinking that they have fixed that problem because they have a API called Tensor Fusion. So it's like in Pytorch, we have something called callbacks. Callbacks pretty much remember the previous session. So Tensor Fusion is sort of like that, but with multiple processes. Now, Fusion APIs have issues with while using with PySpark APIs. But I'm assuming I think that's the only limitation, and I think Horovod is trying to fix their problems. Nothing is perfect, so I think they're trying to fix it. Apart from that, I have not seen anything. We use this in production and we are happy. So I think pretty
Okay,
much
that's awesome.
that way we are set. That way we are set. Yes.
And there is one more question from Alan. It's like, how does Horovod integrate with deep learning frameworks such as TensorFlow, etc.?
Oh, oh, it's very simple. So I know the name sounds incredibly overwhelming, or maybe the process may sound very overwhelming, that distributed, it must be something complex. But what I think commendable is Uber has done an amazing job. Engineers at Uber have done an amazing job at writing this wrapper. I would like to call this as a wrapper because it pretty much integrates with any package that you want to use. So if you're using Pytorch, the integration with Pytorch is incredibly smooth and simple. So you won't find any problem. The community is vast. The integration is also very seamless. I think Horovod also understands that if you're using PyTorch in your production or maybe PyTorch in your project, it understands you're using PyTorch, and accordingly, it is able to distribute its API support according to what you're using. So it's very simple. You just import Horovod, you initialize Horovod, and just use Horovod.tensor, and then or Horovod dot something. It's mentioned in the documentation, and you should be able to integrate it with any existing packages. It has good support with TensorFlow. It has great support with PyTorch and Keras. I think it's okay. I guess it's okay.
Okay, great. Well, with that, we are towards the end of the session, and there are a few comments from the community members where they've said that thank you for joining in, and they're very glad, and so am I. I mean, I think I was surprised when you shared that you were hospitalized and still you decided to show up for the community because you saw that you wanted to keep up on your work, and that's very kind of you, and we really appreciate it, Parth. So thanks a lot for being with us today, and I hope you enjoyed being there on AI Planet. And I'm pretty sure the community would gain a lot of insights. We'll also share it more often. I mean, we'll also share it after this session. You can use the recording to learn from it. So thank you, everyone, and we'll see you next Saturday in the next live session. And yeah, thanks a lot.
Thank you so much, Mudit, and thank you so much for everyone for joining. And I hope I was able to impart some knowledge. And thank you so much for having me.
Thanks. Thank you, everyone. Take care. Bye.